This section is to show removing the sensor from the sample line and filling the membrane cap with electrolyte. So we're going to be sure that we don't have flow in our sample line. Loosen the compression fitting holding the sensor in place. Remove the sensor from its sample cell. Remove the membrane cap. I'm just going to place that there for the time being. Now this particular sensor has a very water-like electrolyte. We're going to fill that cap full. Be sure that there are no air bubbles down where the membrane is inside of the cap. Thread that cap back onto the sensor. Place the sensor back into its sample cell and tighten our compression fitting back in place. We can now start flow in the sample line after we've changed the electrolyte, or if we've first installed the electrolyte. It takes several hours to get a true reading before we want to do our calibration. Some of our sensors have electrolyte that is a little bit more viscous, so to change or to add the electrolyte in that, again, we're going to remove that cap. We're going to fill that cap with electrolyte. Here you can see how much thicker the electrolyte is. We want to fill it, again, so there's no air bubbles. If there is an air bubble, that air bubble will migrate towards the top in time. We'll let that come to the top. Never put a screwdriver or any other instrument into the electrolyte. If you want to try to help remove the air bubble, use the sensor tip itself. We'll now thread that sensor back on. You'll see that the electrolyte will come out. Then we will want to wipe that electrolyte. Never wipe across the membrane itself. Now we can put this sensor into flow. It tends that the thicker electrolytes take a little bit longer to energize, so you'll have to wait a little bit longer to do your calibration. This section of the video is to show some of the programming setup on our D1C-B. This is different from the D1C-A, so be sure to check which model that you have. The first thing that we need to program into the unit once we have wired up the sensor is to match the sensor range and the type of sensor to the controller that we have. To do that, we'll hit the change key until we get to general setting information. We hit the enter to enter this menu and scroll down through. We're going to scroll down until we get to where we can make selections. Here we want to scroll with the up or down arrow button until we highlight the operating menu. In the operating menu, once we hit the enter button, which again is the top right hand button, the first we come to is the operating menu either reduced or complete, and we can change that. It's flashing with either the up or down arrow button. So hit the up arrow until you see complete. Hit the enter. Now we can change down to where measure change is highlighted with the up or down arrow buttons. We hit the enter on that again. This is where we choose or confirm what parameter our unit is for. You can scroll with the up or down arrow button until you highlight what parameter this unit is intended to measure. You see here the dotted line. That dotted line separates millivolt type readings from milliamp or ampemetric type sensors. So you can see the variety that you have to change from on the D1C-B. Here we have a chlorine unit, so we want to highlight CL Here you can see it's highlighted at the top. We'll hit the enter button to confirm that. Now it's going to ask us the range of the sensor, and you'll find that information right on the label that's on towards the top of the sensor. So if we scroll with the up or down arrow button to match what that information is, let's say it's a 0 to 10 ppm sensor. With the enter button again to confirm that, you see the unit goes back to our main screen. The next step in basic setup would be to set up the calibration. You'll see that on a D1CB, once you change the measuring range, or in this case we've also confirmed the type of sensor that we have, the first thing that it insists that you do is a calibration, and it will give you an error code on the far right hand bottom corner of the display until we do that calibration. To do the calibration, hit the change key. We actually want to put it into the reduced menu first. So we have to go back until we see general settings information again. So hit the change key until you see general settings. Hit the enter button. Hit the enter button a second time. Now we can scroll until with the up or down arrow button, until we get to where operating menu is highlighted. Hit the enter button once. We'll change it back to reduced with the up or down arrow button. Hit the enter, top right. Now we can hit the bottom center key twice to get back to our main display. From there, to do the calibration, we hit the change key until we see calibration. We hit the enter. It's asking us what that value is. You see that value is flashing, 2.81 in this example. It's very important that we pull our sample at the moment we go into this screen where that value is flashing. That's what the reading is representing. So we'll pull our sample and do either a DPD test, or depending on what parameter, you might have to do a titration. But we get to know what that value is of our sample. Now we can make that match with either the up or down arrow keys. Here we change a digit. Change the digit that's flashing. We hit the change key. Now we can change this digit if we needed to. Hit the change key again. Now we're on the right side of the decimal. Change key to the last digit. We can change that to match whatever we want it to be. Ultimately, when you're finished and it matches what you came up with as a result of your test, you hit the enter button to accept it. It flashes as a complete number. It just wants you to verify again that that's what you intend. You hit the enter button. It tells you what the resulting slope is of your calculation. Here it tells us 1.2 milliamps per part per million. That's the default slope value for a 10 part per million sensor. It will accept the slope until we go down to 25% of that initial starting slope. So 0.30 would be acceptable. If the resulted calculated slope is below that, it will not accept the calibration. Hit the enter button again. You'll see it moves on to the next menu. We don't need to pursue that any further. We can hit the bottom center key, get back to the main display. You'll see that calibration at the bottom has gone away, and our error at the bottom has gone away as well. The next thing we need to do as simple startup or simple setup on a D1CB would be our set point. To get to the set point, we hit the top left-hand button, the change button, until we see control settings. We enter that with the enter button, the top right-hand button. Continue to hit the enter until you get to set point is flashing. You'll see that here the set point is at 5 ppm. The set point goes to half the measuring range. Keep that in mind if you change that measuring range and change it back. Several things go to their default setting, including this set point. 5 parts per million could be rather high for a lot of processes, so be very aware that that also goes back to our default setting. Once we hit the enter button or the up or down arrow button, the first digit starts to flash, so we can set our set point. We want to change that to maybe 1 part per million. So whatever digit's flashing, we need to hover on. So we hit the change key until we're hovering on that digit. Then we hit the up or down arrow button for whatever's flashing, and we can change that. We're finally finished. We can hit enter. The complete whole number flashes again. Just to verify, we hit enter once again. Next it goes to, this is our proportional setting. We're going to cover the PID settings in another video. You can hit the bottom center key twice to get back to the main display, and we're now set for a 1 part per million set point. Here we're well above 1 part per million. You can see that the dechlor pump would be pumping with the indicating flashing block at the top right. And that's how we set up the basic parameters for an ampimetric or a chlorine type sensor on a D1C-B.